Okay, hi, I'm Ethan Kwan, and today I'm going to be showing you, the reason I normally use Universe Sandbox 2 here, as you can see, is to see how Earth was created, but this time I'm not going to do that. This time, what we're going to do is we are going to explore a new planet, who holds the record for the hottest planet, I think, holds the record for the hottest planet in the galaxy. I think. I haven't seen any other ones like this, but okay. So, this planet is orbiting a star, kind of like, let's see, a big star, like Sirius. No, that's a white dwarf, isn't it? Okay, what's down here? Vega, Ferenhite, big, too big. This one's the smallest. Well, smallest white one I can find. Oh, whoa. Sirius is... This is a star, isn't it? Okay, so this planet is orbiting a star like this one. It's a blue star. And blue stars, as you know, are very bad for life. And also, okay, so here's what it looks like. It's 3 times the mass of Jupiter. Okay, one sec. Go up. Okay. So, this planet is kind of weird because it is 3 times the mass of Jupiter and really, really, really close to its star. This Jupiter right here is hot, like really, really hot. Now let's see if I can cool it down. I don't think so though. Okay, so surface, what's the hottest? 2000, okay, so negative 66. Oh yeah, now it's getting hot again. Oh, okay, so as you can see there, that was a very failed attempt to make it cold because it's so close to its parent star that basically any attempt is kind of dumb. Yeah. Well, this is not exactly what I was hoping that would happen, so let's try in a new simulation what might happen. Okay. So, I'm going to add, well, this works best with, like, small stars like this guy. Like Proxima. Now, it is not orbiting Proxima, but it is orbiting far away. I'm actually not sure how far away, but anyway, this planet here is so close to its star. Let's see, so... Whoa, that's actually... Whoa. Okay, you know what? Okay, so this planet here is so close to its parent star that basically its year, well, what you'd consider as its year, would actually be like, well, it is a guess. Okay. Pause the video and comment your guess down below. Okay? No. Yeah. Just guess. Seriously. It's not hard to guess. Okay. So, I can pause the video right now. Okay, I'm hoping you paused it and guessed because the planet is so close that it will orbit its star. Let's see. It will orbit its star. Let's see. Where is it? It will orbit its star. Actually, that was pretty close. So it will orbit its star every, drumroll please, 1.5 days. Well, yeah. So this close. So as you can see that there's this stream of material that's coming off Jupiter right now. And that means it's losing mass, which is good. So its orbital period is 1.5. That means it's rotational period also has to be 1.5, not 9.92. Should be 1.5. Okay. Perfect. Okay. So now one side of the planet is always facing the star, and one side is always away. Check it out. Okay, so now we have a planet that is so hot. Well, this is not hot. I'm going to put it at 699 degrees Celsius. As you can see, one side of the planet is so hot, and one side of the planet is so cold. So, see, there are major temperature differences, and now we can actually see where the star is by just like looking at the red spot. So one side is always facing, and one side is always facing away. And how these planets form is actually really cool. Okay, so they're called hot Jupiters, and this is a special type called super hot Jupiter. Well, the kind of I made that up, kind of, but okay. So now we have. Okay, so let me show you how hot Jupiters form. All right, so let's do this in a new simulation. Okay, so we know how the sun formed, and let's just do it around a normal star, like the sun, and then we'll do that. Okay, so now we're going to put a planet in. Let's just put Jupiter in, and we think that, okay, so, well, Jupiter's like this far away anyway. No, it's not. That's like too far. But this is how Jupiter kind of formed. Well, and this is how Jupiter, this is how hot Jupiters form. So, Jupiter, if Jupiter became a hot Jupiter, okay, so Jupiter, if it actually became a hot Jupiter, would be actually, so when this early solar system formed, the material banging into the planets, all the dust and gas and rocks, it will actually slow it down by pushing through all that material. It basically got kind of like, what's the word? It kind of got dragged, and it kind of spiraled in. So we can simulate this by going into motion and then slowing down the speed. Now, it might take a while for it to happen, but as you can see, our Jupiter is actually starting to spiral in. Okay, so let me just slow it down a little. Now, as you can see, the orbit is getting more and more curved and getting pretty close. Okay, so I'm gonna slow down even more. So as you can see, our Jupiter is actually in like a death spiral toward the sun. Now, this is over-exaggerated. It would take a lot less time than this. It would take a lot longer than this. But yeah. So we're zooming in on Jupiter. Okay, so let's keep an eye on the temperature. Okay. Okay, so I'm gonna keep slowing it down. What the? Weird. AU. Put this at 5. Sorry, it kind of got messed up here. weird. So it's at 5 AU, and then what I'm gonna do is I'm gonna auto orbit. Okay, much better. Okay, so I'm gonna retry that because that was kind of weird. Okay, so as you can see, it's spiraling in. Okay, so this is kind of how it formed, by basically spiraling in toward the sun like this. Kind of strange. Where does it go? Okay, so as you can see, that's kind of how it formed. Now, this planet is so hot that, let's see if I can redo this. Okay, so go to Wolf. I don't know. It's Wolf. I don't care. Well, it's actually really big. Small, I mean. So Jupiter will be about this far away, and it will be really hot. Well, hopefully. Okay, so let's keep an eye on the temperature. You know what, I think it has to move closer. Okay, so edit. Let's move it in closer. Now I'm gonna just go in and auto orbit it. Whoops. Okay. So auto orbit. And then I'm gonna go back to Wolf. Okay, so as you can see, it's getting warmer, not that fast, but this kind of happened where it was getting really hot. So as you can see, Jupiter is getting hot. So as you can see, the temperature is going up, and this is kind of how it formed. So this planet, actually, I haven't told you the name yet. So the name of this planet is actually Kelt 9b, and it is tidally locked, which means that one side of the planet is always facing toward the star, and one side is always facing away. And you can simulate that by, let's see, so it's orbital period 22.0 hours. There should be 1 point. Okay, fine. 22 hours. That's good enough. It normally is 1.5 days, but yeah. So orbital period is 1.5 days. Where's the other one? I'm looking for the rotation period. Where would that be? Where's the rotation period? Weird. Okay. Rotation period might be here. Okay, so I'm just gonna cheat and put this to 100. Or 10. Okay, so as you can see, it's heating up. And if we speed this up for long enough, the temperature will get really, really hot. 144. Technically has to get like really hot. Whoa, look at the shapes. Weird. Okay, can't run any faster. Oh well. Okay, so the temperature is not that hot. So yeah, this is not gonna work, is it? Okay. So that's kind of how it works. So actually you can actually see it. It's actually really cool. So okay, so let me just do this with a random gas giant. What I'm gonna do is I'm gonna laser it. Sorry. So laser, and one side is so hot that it will do this. Yetawatts. I'm gonna put 1. This is gonna. I'm sorry. Yeah, so as you can see, it's very hot. You can say that again. So let's see. So I'm gonna put zetawatts. 1 zettawatt. That's still pretty hot. And I'm gonna let this cool down. So one side of the planet will always be super hot, and the other side will be. One side will always be nighttime. So one side will be plasmid, and the other side will, well, the other side is going to be super cold. I don't know what is happening right here, but it's not good, is it? That's not what's supposed to happen. Okay, so basically that's how it works. So one side is really hot, one side is super cold, and the hot side is so hot it is at 4,300 degrees Celsius or 8,700 degrees Fahrenheit that it's plasma. So plasma is basically electrons, protons, and neutrons that get separated and torn apart from themselves, and like it's just like a goo kind of thing. Not that I've ever touched it, but it's kind of like a goo. I think. Okay, so that's what plasma is. So plasma forms on the hot side, goes to the cool side, and on the cool side, it's cool enough to, not that kind of cool. It's cool enough to make atoms. And until they go on to the hot side again, of course. And yeah, so yeah, that's basically it. That's kind of how that's a pretty cool planet. It's called Kelt 9b. Sorry I couldn't make a simulation. But it's actually really cool. Okay? Okay. So, without further ado, let me just okay. So, see you at howtodostuffwithethan.com, and see you next time. Bye. Bye.